good morning students, and welcome to the digital classroom of General Science. Dear students, today we are going to start with a new lesson number 16, reflection of light. And I am pretty sure that you all had completed your workbooks till lesson number 15. And as I had told you, if any of the lesson is incomplete, now you all are coming alternate days to the school and we are meeting in the school. So if any of the lesson is incomplete, you can bring your workbooks in the school and you can complete the workbook exercise in the class also. Okay, so let's start with a new topic, reflection of light. We have studied about the sense organs in the previous classes, and those 5 important sense organs are skin, eye, ear, nose and tongue and skin. So these are the 5 sense organs. Now each sense organ performs a different function. Now here when you look at these pictures, which sense organ is used? It is the eyes, right? That is the sense of vision, and the sense of vision is one of the important of our all the 5 sense organs. We can see around us everything because of the eye, because of the vision of sense. Now suppose you are sitting in your room and the lights are off and the doors or windows are also closed. There is pitch dark in the room. Will you be able to see the things around you? Yes? Will you be able to? No, because there is no light. And when light is not there, we are not able to see the things around us. Why? Because when the light rays, they fall on the objects, and from the objects they are thrown back, and when they reach our eyes, then only we are able to see the objects, and this is nothing but the reflection. Now when we are sitting in a dark room, there is no light, doors and windows are closed, we are not able to see the things because the light is not falling on the objects, and after falling on the objects, the light rays are not reaching our eyes. Unless and until this light which falls on the object does not reach to our eyes, we are not able to see the things. So this is called as reflection of light. Because of the reflection of light, we are able to see the things around us. So when light rays falls on an object, their direction changes and they turn back. This is called as reflection of light. Now in the second picture, you can see that the boy is standing in front of the mirror and he is able to see the image of him in the mirror because the light rays are falling on the mirror and then they are reaching his eyes, and thus because of the reflection of light, the boy is able to see the image. But if the room is dark and there is no light, then the boy will not be able to see the image in the mirror because the reflection of light will not take place in a dark room. So reflection of light is when any light ray falls on an object and their direction changes, they turn back and reach the eyes, the person is able to see the object. This phenomenon is called as reflection of light. Now students, there is an experiment. Now as you know that we were very happy to start with the physical school and you had started coming to the school, and we were so happy, and we had started enjoying the classroom teaching and you the classroom learning. But unfortunately, due to the second wave of corona, we have to close the schools as per the GR received from the government. So we cannot perform this experiment, but with the help of this experiment, we will be able to learn, we will be able to come to know. So we are going to observe an experiment in which the requirements are torch light, a torch we require, a mirror, black paper, white paper, and glass stand. We have to fit the paper tightly over a table or the drawing board, and leaving some portion in middle of the comb, we have to cover the rest with black paper so that the light can only pass through the open central pore, right? Then we have to hold the comb perpendicular to the white paper, and we have to throw torch light on its central portion where we have made a hole. And we have to adjust the comb and the torch in such a way so that the light rays falls on the white paper. And now we have to keep a mirror in the path of this ray of light as it is shown. Now here what happens, the light rays which fall on the mirror, they get reflected and travel in a different direction. Their direction changes. The rays falling on any surface are called the incident rays. These are the incident rays. Okay, the small one, this is falling on the mirror and it is changing its direction, and this one is called as reflected ray. Okay, and this point where the ray is falling on the mirror and is changing its direction is called as the point of incidence. So this is the incident ray, this is the reflected ray, and this is the point of incidence. Now the direction of the reflected ray is decided by some rules which are called as laws of reflection, and that we are going to study now. Okay, so this was a small experiment to make you understand that when a light ray falls on a mirror, the ray which falls is called as the incident ray, and the point where the ray falls on the mirror is called as point of incidence. And when this ray, after falling on the mirror, changes its direction and goes back, this ray is called as the reflected ray. Now as you can see in the picture, the reflection of light. Now with the help of this, very easily you will be able to understand, right? Now in this we had drawn a line PQ, right? PQ is the line which shows the position of the mirror. Then we have to draw a normal at the perpendicular at the right angle of this PQ, and then we have to draw an incident ray which is AO, right, and the reflected ray that is OB. Now here the angle between the incident ray and the normal, that is AON, that is called as angle of incidence, and the angle which is formed between the reflected ray and the normal, that is BON, is called as angle of reflection, and the normal is at the point of incidence, right? Now with the help of this, we will study the laws of reflection. Okay. Now with the help of all this diagram, we will come to know the laws of reflection. Now the first law of reflection is the angle of incidence is equal to angle of reflection always. This is the first law of laws of reflection. So angle AON is equal to angle BON. That is the first law of laws of reflection. Second law is the incident ray, the reflected ray and the normal lie in the same plane, as they are all three on the line PQ. They are in the same plane. So incident ray, reflected ray and the normal are always in the same plane. Now the third one is the incident ray and the reflection ray are on the opposite sides of the normal. Okay. They are always on the opposite side of the normal in the center, and incident ray is on one side and the reflected ray is on the other side. So these are the laws of reflection. Now the next we are going to verify the laws of reflection, whether the laws of reflection are really taking place. Whatever those 3 points are there in laws of reflection, are they actually true? So we will just verify with the help of an experiment. So we will perform an experiment. We have to take a white paper, and on the white paper we have to draw a line PQ, right? This is the line PQ, and we have to assume as if this is the position of the mirror, and then we have to draw a perpendicular ON to PQ at the point O. So at the line PQ at the point O, we have to draw the perpendicular ON, and then we have to draw a ray AO, which is the incident ray, and the angle AON should be 30 degree. That is the angle of incidence. Now we have to fix 2 all pins at S and R point on the incident ray. Now we have to look at the reflection of this incident ray from the other side, from this side of the normal. Okay, and looking in the mirror, we have to put these pins at 2 places U and T, where we see the image of the reflected ray. Okay, now we have to join these 2 points and we have to draw a line, and this line is the reflected ray and the angle is between I, O and N, right? That is TON, we can say. Now what we have to do is we have to measure this angle of reflection, and when we will measure the angle of reflection, we will find that this is 30 degree Celsius, right? So this verifies that the angle of incidence and angle of reflection are always equal to each other, and they are on the opposite side of the normal, and the incident ray, the reflected ray and the normal are at the point of incidence and they are on the same plane. So this is proved by this experiment. And what we had taken for this experiment, the requirements were mirror, drawing board, pens, white paper, protractor, scale and the pencil, right? Now you can perform 2 more experiments like this. Instead of SR, you take another incident ray at an angle of 45, and then you can verify that the angle of reflection will also be 45 degree Celsius. We can then again move on and we can form a third line at 60 degrees Celsius, and then when we see the reflection of this incident ray from the other side of the normal, we will put 2 pins and we will draw a line joining O with these two pins, and we will see that angle of reflection will be angle of incidence, that is 60 degree Celsius. So this is how we can verify the laws of reflection. Now we will see what happens when these rays of light falls on a smooth surface and a rough surface, right? So we'll just see the first one. What happens when the rays of light falls on a smooth surface? Now the reflection of light from a plane and smooth surface is called as regular reflection of light, whereas from a rough surface it is called as irregular reflection of light. Now why is it called so? We are going to understand this. Now in the smooth surface, when the rays of light falls, the reflection is regular. Now angle of incidence is always equal to angle of reflection for all the parallel rays. Now it is a smooth surface, so the angle of incidence, the rays of incidence will always be parallel, and similarly on the other side the angle of reflection are also going to be parallel to each other. So if the angles of incidence for the incident rays are I1, I2, I3, then their angles of reflection will be R1, R2 and R3. And the I1 is equal to I2 is equal to I3, and it will be R1 equal to R2 and equal to R3. So such type of reflection of light on a smooth surface is called as regular reflection of light. Now let's see what happens when the light rays fall on a rough surface. Now the reflection of light from a rough surface is called as irregular reflection of light. Now why it is called as irregular reflection of light, students? Because in irregular reflection, the angle of incidence for parallel rays of incidence are not equal, and therefore their angles of reflection are also not same. So in the regular we had seen I1 is equal to I2 is equal to I3. Similarly R1 is equal to R2 is equal to R3. But when the light rays are reflected from a rough surface, I1 is not equal to I2, not equal to I3. Similarly, R1 is not equal to R2, not equal to R3. Thus, the reflected rays are not parallel to one another and they spread over a large surface. So, this is all about the regular reflection of light and irregular reflection of light. Now students, these points you have to always remember, that laws of reflection are found in both regular and irregular reflection. And second is reflection of light from irregular surface is not obtained because the laws of reflection are not followed. They are obtained because the surface is rough. It is irregular reflection. And in irregular reflection, the angle of incidence at different points are different. But at any point, the angle of incidence of that ray will be 100% equal to the angle of reflection at that point. Okay. Now next we are going to study about the reflection of reflected light. Students, when you go to the parlor, girls especially and boys when they go to the salon for cutting their hair, they might have observed that in the salon generally the mirrors are placed on both the walls. Now when you sit in front of the mirror, what do you see in the mirror? The image of the back of our head is formed in the mirror at the back. Now, this image is formed in the front mirror because of the reflection of rays which are falling on the back mirror, right? And thus we can see at the back side of our head also how the hair are being cut. Then next we have to study about the kaleidoscope. Now kaleidoscope is, you can say, I hope every one of you might have heard about it. Maybe you don't know the name, but you had seen this instrument, this, I can say, toy in your childhood, I would say. Now, for making a kaleidoscope, we have to take three rectangular mirrors of the same side, as you can see in the picture, three rectangular mirror. Then we have to stick them together, making a triangle. As you can see, these three mirrors are stick together and a triangle is made, due to which all the mirrors are facing each other. And then we have to place it inside a triangle shape or a round shape box. Okay, and then the other end is closed. From the open end we have to insert some few pieces of the glass bangles or glass pieces, and then we have to close the other end of also with the help of a paper, and in the center we have to just make a hole. Okay, now as we look from this hole, we are able to see the different images inside. These images are seen because of the mirrors. Now we see different designs in it. Now, what is the speciality of this kaleidoscope? The speciality of this kaleidoscope is that designs are not repeated by themselves every time you get a new design, right? So this is a kaleidoscope, and this is generally used by the people who make the wallpapers for decorating the wall, or the cloth designers, and they use the kaleidoscope for making new designs, because every time they get a new designs with the help of a kaleidoscope. Next, we are going to study about the periscope. Students, have you heard about the submarine? Submarine is found under the sea waters, right? And only when the need arises, it comes above the surface of the water. Now, when the submarine is under the water, how the people or the one who drives the submarine is able to see, and how he drives the submarine? Does that question arise in your mind? Yes. Now here the use of periscope takes place. Now as you can see in the picture, students, in the first one the periscope is there, and in the second one we have shown how the working of periscope takes place. Now this can be made. I will just repeat the procedure how you can make this periscope at home. Now we have to take a cardboard box, and we have to make slits on the bottom and at the top of the box, and we have to place two mirrors in such a way that they face each other here. Okay, these are the two mirrors which are facing each other, and they are at 45 degrees of angle, right? Both are parallel to each other and they are at 45 degrees from the sides of the box, and then we have to stick it. Now we have to make two windows of 1 inch each near the two mirrors, here, okay, as well as here. So these are the two windows which we make, and they should be around 1 inch big. Now you watch from here and find out what you see. Yes, from the bottom window we can see what is happening on the other side, right? Similarly, this is used in the submarines, right? Now you can see the submarine inside the water, but the periscope is above the sea water, above the level of the sea water. So with the help of this periscope, the person who is inside the submarine can see on the surface of the water what is happening. So this device is called a periscope, and this is used in the submarines, as I said, to see what is happening on the surface of the water. So all both these periscope and kaleidoscope both are made, both work on the laws of reflection of light. So with this we finish with the lesson. It was quite a small lesson. We had studied about the reflection of light, the laws of reflection, the verification of the laws of reflection, and then we had also studied the regular and irregular reflection from smooth and rough surface respectively, and we had studied about reflection of reflected light also, and in the last we had seen how the periscope and kaleidoscope work and on what principle they are made. Okay, students? So next time in the next science period, we are going to discuss the question answers of the same lesson. So please find out the answers and please be ready with your textbook, your workbook, and pen, pencil, whatever is required to note down the points. Thank you, students, and please take care.